Hello everyone, welcome back to the channel. Welcome back to another video in our data structure algorithm series, right? So as you see in last two videos, first video we talked about, what is an array, how do you declare initialize, and what are the problems with the array, right? And basically static array. And then we implemented the dynamic array, which is our own custom array list, right? Where we have seen key without that ensure capacity method, we get that array index out of bound exception. And with that with this single line of code, which is this particular line, our array grows dynamically, and we with just this single line of code we created a dynamic array, right? We have also looked into few methods in our array list, right? And you can go through those videos also so that you understand this one in a better way, and I guarantee that you will understand that. Now in this video, what we'll be discussing, we'll be implementing these methods: removeAt, and indexOf. This remove method, it will be just removing the values from the last index, and removeAt will be removing the values at the given index, and indexOf will be returning the index of the particular value that we are trying to search. Right? Let's implement these methods right away. Let's start with the remove method. Public int remove. So this is very straightforward. We can just have, I think we'll try to return itself. Return. I have an items array. So what I'm trying to do, I'm trying to return the last array, and I'm trying to reduce the size. So I can reduce the size, and I can provide that particular array. Let's say this single line should be enough to remove the element from the last index, and it will reduce the size as well, right? Let's check the size of the actual array. Let's change it to size only, so that we can print our elements to that particular size. Okay, let's see if our remove method is working. So list dot remove. Now what we'll do, we'll just try to, okay, we'll also see what we removed, right? Let's close this and then print our list again. List dot print. Let's see what we get here. So we are getting, what is it we are getting? Okay. So after this, let me put a sys out as well, so that we can see what's happening in the, so whatever methods that we have written right here, we'll be able to see what is happening there in the next line properly. So that is the only reason I have added a sys out here. So see what is the element that we have removed? 60, right? So 60 is the last element that we have added in the array, and before removing, if I print this size, right, the size was 6 basically. Now if I print the latest size, let me copy this method. I mean, although it's a single line, I mean copy pasting is not going to hurt you that much. If you know the implementation for the first time, you have to do it manually, then you can copy the code as well. I mean, that's not going to hurt anyone. So now it should be 5, right? Okay, okay, that's fine. Sys out. So let me tell you what's happening here. We have removed this 60 from the array, right? And the size is now 5, which is correct. So our remove method is working as expected. It is what it is doing. So it is removing the elements from the last index, right? So that was the remove method for us. Now let's talk about removeAt, right? Public int. I'm providing int so that I can see what is the last value that we are returning. There is just so much noise that is coming from the outside. This is 2 o'clock. Ganpati celebrations are happening outside. Ganpati Bappa Moria. Public int. Let's continue our implementation, right? These are just two methods, right? I hope you will able to understand. If the noise is too much, okay, it's not live, how will you let me know? But let's continue the implementation for now. Public int removeAt, and this is the index. No, actually removeAt index only, yeah. So what we're trying to achieve from this removeAt method? Let's continue, we'll see that. So what we're trying to achieve in this removeAt method? So we want to go to this index, return whatever value is there, whatever value we are removing, I just want to return that, right? We are returning, and then what we are doing, then we want to move all the elements from that index till the last index. Okay, so let's see what we are doing. We are trying to achieve here. We want to remove the value at this particular index, and then we want to shift all the elements from that index till the end of the index in that particular array, right? So how we can do that? First of all, let's save that particular value, int removed element is equal to items of index. Before that, we want to check if this if this index that we are trying to check, right? So we want to verify कि this index that you are trying to remove value for, right, it should not be equal to -1, right? And and your index should not be greater than items dot length. That means it should not be beyond the array length, right? Okay, items dot length -1, because the length will be, index will start from 0. That's why I'm putting it in -1 there. Okay, I think this condition, what we want to do basically there, throw illegal argument exception, right, telling that wrong index value. Throw new illegal argument exception, wrong index value. Okay, so now let's shift all the elements from that particular index. I is equal to index. So I is equal to index till items dot length -1, right? What we are trying to do here, basically we want to shift all the elements from till that item, this index. You want to shift the next value to this current value, items of index +1, and this should not be -1, this should be -2, because the last value anyways we are reducing. Let's and we want to do this if index that we are passing, right, it is not the last index, because if it is the last index, what is the point to iterate through the whole array and then shifting all the elements? There is no point of it. If it is not equal to the last index, and terms dot length -1. So if it is not last index light, then only we want to do this. if it is the last index, then what we want to do, we want to just reduce the size minus minus, that's it, and we'll return the removed element that we removed basically. Now we should not get any warning from the method. Okay, that is gone, you see. So in this method, what we are trying to do, first we are checking if our index is in the correct valid range or not. If it is in the valid range, then go ahead, otherwise throw the exception there itself, throw the illegal argument exception telling the end user that it is the wrong index value. Then we just stored that particular index value so that we can return it. And if the index that we are trying to remove value for, right, if it is not the last index, then only iterate and shift these values. If it is the last index, then just reduce the size and that's it. If it is not the last element, right, then shift values from that index till the end of the array, and then remove the element that we have stored. That's it. Let's test this implementation. So what I'm trying to do is I'm trying to remove list dot removeAt. So let's say I'm trying to remove the element at second index, that means this 30, right? So now we should get here 30, and in the next, let's try to print the size again. Sout list dot size. Let's print and see what we are getting. So you see we are getting 30, which is this element we have removed, right? And now the size is 4, right? So now if I try to print, let's print the list itself so that we can see that 30 is removed. List dot print. Let's print it. Now we should be able to see 10, 20, 40, 50. 40, 40. We did something wrong there. Okay, so there is a small mistake that we did there. So instead of checking for size, right, what we are checking with the items dot length. That is the full length of the array, full size of the array, which was actually 8. But the element that we had in the array list, right, was less. So now what I have done, I have just replaced it with the size, and we are doing every calculation with the index. So if we have taken, if the index is not the last index, right, then from that index till the last index, shift all those elements and then reduce the size. So you see what is the result that we are getting. So yes, we have removed the second index value, which is 30. Now the size is 4, earlier it was 5, and 30 is gone, as you can see. Now we have 10, 20, 40, 50, right? So you saw how the removeAt in the method is working, right? Let me just give you a brief view on that. First we are checking if it's a valid index. If it is not valid, we are throwing illegal argument exception with the message. Then we are storing the value that we are removing. Then we are checking if it is not the last index, then only shift all the items from that particular index to last index, and then reduce the size. And if it is the last index, directly go ahead and reduce the size, right, and return that particular element that we have removed. Nothing else that we are doing here. See how simple it is to implement and understand, right? So now we'll be implementing the third method, which is actually very simple. We're just trying to return the index of the particular value. Public int indexOf int value. This is very straightforward. I mean, we just created a loop from 0 index till size, and then what we are trying to check, if items of I is equal to value. If it is equal, then return that particular index. If after the whole loop you are not able to find it, just return -1. As you saw, that is the same thing what we are doing in the actual implementation as well. If I find that index of method something, right? So this is doing the almost similar thing, right? In the end, if it is not able to find, it is returning -1, or else it is returning your particular index. So I think that's it. Let's go ahead and check the index that we are trying to search. List out list dot index of, let's say I want the index of 40, right? Now 40 index is what? 0, 1, 2, right? Now we should be able to get 2 after this, which is what we are getting. So our implementation is correct. But what if you let's check the same thing with the incorrect value as well, right? So let's say I'm providing 400 instead of 40. Now we should be able to get -1, right? So we are getting -1 as well. So our implementation is working fine, right? So I think that's it. This is a very simple implementation. Here we are iterating through the whole array. So for this, time complexity is O of n, because n considering the number of elements in the array. So considering that, it becomes O of n, right? For the removeAt, that is also O of n operation, because if you're trying to remove just from last index, it will be O of 1, that is constant time complexity. But if you want to remove from the index somewhere in between, or let's say first index itself, right, then you have to literally shift from that particular index till the end of the array. That becomes O of n operation. Similar way for the add method as well. When you are directly trying to add the value at that particular index, right, in the static array where you had to provide the size in advance, there it was O of 1 operation, constant time. You just directly set the value at the particular index. But in this one, you are checking if the capacity is enough to hold the new element, because array list is going dynamically, right? So here ensure capacity is also called, where you are actually copying all the elements of the old array to new array. So copying all those n elements is again an O of n operation. So the time complexity of this add method also becomes O of n, right? And this, in this remove method, this is actually removing the items from the last index. So this is an O of 1 operation, which is constant. There is no loop, nothing. Straightforward, we are reducing the size and returning it the element, O of 1 operation. So I hope you were able to get the idea on what I'm trying to explain here, right? This was a very basic implementation of the custom array. This is the array list that we created on our own with the add method, ensure capacity, one-liner method that creates a dynamic array. Print method, nothing extraordinary in there. Size method, we are just returning the size. Remove method, which is removing the last element. removeAt, which is removing the value at a particular index. indexOf, returning the value at the particular index. And that's it. You see, nothing rocket science there, right? In this particular array list, right, I would encourage you, there are a lot of other methods as well, right? indexOf range, convert it to array, and there are a lot of other methods as well. So you can just go through this particular implementation and see how they are implemented. It's very easy. If you are not able to understand, feel free to comment on the video. I'll be explaining that. So I hope this video was informative to you, right? And that's it. I'm trying to put an end here on the array list as a concept, right? We'll be creating separate playlist for the those lead code small, easy, medium and hard problems, right? This whole playlist will be focused on understanding the concept with their implementation, right? I hope you are able to understand what an array list is, how it grows dynamically, about all of these simple method implementation that I have done in front of you. So this you can do it in actually just 10-15 minutes, this whole implementation. Okay, so there is a small correction in the removeAt method, which is actually we were taking this particular index itself, right? So I have taken this index directly. So here all we are performing, all the operations that we are performing, right, this shifting operation that we want to perform with our own variable. So instead of taking index everywhere, right, we are just considering assigning that value to our own variable and using that variable everywhere to, you know, do the whole shifting. We are checking for that variable is less than size or not, and we are using the same variable to shift the elements. So that is the only modification that I have done here. It was showing some warning that if you are using the same variable which is passed in the argument, then why you are trying to declare it again, right? So that was the issue. That is the only issue that I wanted to correct here, and that's it, nothing else. And that's it. For next video, we will be kicking off on linked list, which is again basic data structures. A lot of other data structures are implemented on top of this array and linked list. So let's make sure we understand these first before going into the advanced data structures, right? So yeah, may the source be with you. See you in the next video. Till then, enjoy.